So I have here a Huffman compression engine project that was coded in C, and so we have a lot of C files here that are in our source directory, and a common way to compile our program with all these C files is to use what is called a Makefile. So here we have the Makefile here, and then all we have to do is type in make, and then it's going to compile our program, and then if you look here, there's a bin directory that's made, and then our executable here is in the bin directory as well. So we go into the bin directory, and then there's our executable. So here's the executable, and then we just use -c to do compression, and we're going to compress this lesmiserables.txt. So this lesmiserables.txt is in our test folder, and this is what it looks like. So it's this long ebook here, and we're just going to use our program to compress it. And there you go. So this is how we build our program, and then we can run our program. Now when you're looking at the Makefile itself, it kind of looks like it's its own programming language. There's a lot of different symbols here, and it looks kind of confusing. But what I'm going to do in this video is show you how I came up with this Makefile and go through all the steps so that you can create your own Makefiles for your own projects. Makefiles, in my experience, really helped me conceptualize this idea of compiling and building programs and applications. And when I was in university, our professor never taught us how Makefiles work, or maybe he spent like one lecture on it. So this is why I'm creating this video, to help you out. My name is Henrik, and I'm here to help you learn the foundations of software development, and I have a free guide for you called my High IQ Software Checklist, and it's just a free guide that you can download that has a checklist of all these high IQ principles that I've learned over the years as a software developer at my company, and you can use it to audit your own code bases and just make sure that you're following some high IQ principles. So you can download that in the link below. Alright, now let's create this Makefile together from scratch. So you probably are familiar with compiling your code like this with GCC, and then we have some flags, and then our main.c program, or whatever C program you're compiling. So what we're going to do first is we're going to code our CC variable. So CC just means C compiler, and then we're going to specify GCC as our compiler here. And then we're going to create another variable called CFLAGS, and then this will just be the flags that we use. And these flags here are just for making sure that when we compile our code with the Makefile, we don't want to ignore all of the warnings. We want to see the warnings. So this is why we're using these flags. And then we're just going to take main.c, and then we'll compile it here. I'm just going to add these flags here. This tells which C standard we're going to use. And then this is also going to tell where we're going to look for our header files. So we're going to look for our header files in this include directory. So you can see our directory here. We have a include directory up here, and this is where all of our header files are. Alright, now we're going to make rules for our Makefile that tell Make how to build files and what they depend on. So there are 3 components for every make rule. So the first one is target, and then we have prerequisite, and then recipe. Okay, so here's a typical example. Main.o is the target file that we're going to make, and it depends on main.c, and then this is the recipe for how we create main.o. And you have to make sure you use a tab here. This is how Makefiles work. So this is how we build the main.o file, and what it does is it checks if the main.o is newer than main.c. If it's newer than main.c, then it doesn't execute this rule, but if main.c is newer, meaning it has been modified, then it will execute this rule because it knows that main.o needs to be regenerated. So here we're going to replace GCC with our variable here, and we're going to add the C flags here. So you see the value of these variables. We don't have to write GCC every time, or we don't have to write all of these flags every time. We can just use them here in the Makefile like this. Alright, so I created rules for all of the C files in our source directory. So we have main.c here, that's the target is going to be created, main.o, so the object file for that, and then the encoder, decoder, frequency, priority queue, tree.c, details.c. So we're going to create all of these object files, and then we're going to have a Huffman executable that's going to be generated from all of these object files, and then we're going to use this recipe to bring together all of the object files, and then we're going to use -o to create this Huffman executable. Alright, now we're going to create this clean rule, and this clean doesn't have any prerequisites, but it just has a recipe where we remove all of the object files and the Huffman executable. And then we have this .phony clean just to tell Make that clean is not a target or a file. It's just a command that we're going to do. So we're going to do make clean, and then it's going to run this recipe here. So let's go ahead and run this Makefile. So we run make, and there you go. So it compiled all of our files, all of the object files first, and then it compiled the Huffman executable at the very end. So if we do an ls, and then you can see the Huffman executable is over here. And if we do a make clean, and then it removes all of the object files and the Huffman file, so now everything is gone. Now we do also want to add a rule for all. So we put the all rule at the top to make that the default rule that the Makefile is going to run. So we're going to add all here, and we're just going to specify the executable, and this is what we're saying, that this is the main thing that we want to build for this Makefile. So if we do a make all or we do a make, then we're going to create this executable. But at the bottom we also have to include all in the phony to make sure that we specify that all is not actually a file, it's a command that we run with the make. Alright, now as you can see from this Makefile, it's kind of annoying because each C file has its own rule. So we can actually make this Makefile a lot simpler, and if we create new C files, then we don't have to update the Makefile every time. So we can update our Makefile so that it will automatically look for all of the C files, compile them all together into this Huffman executable. So what we need to do is we need to create a new variable called sources. So we'll do srcs, and then we're going to use something called wildcard. So we do this wildcard src / star.c. So this sources variable is just going to have a list of all of the C files in the source directory. And then from this sources variable, we can create a list of object files. So we're going to do objs equals, and then we're going to use this sources, and then we're going to convert all of the C files. So what this objs variable does is it takes that list of C files and then it turns it into a list of O files. So this main.o, encoder.o, these are all O files that are generated from the C files. So we can actually, this is basically what the objs variable is. So we can replace this one with the objs variable. So see, doesn't that look a lot cleaner instead of having a list of O files that we typed out by hand? Also, that list of O files may change depending on how many new C files we're adding to the project. So this is a nice variable to use. So next what we can do is you can see that there's a pattern here. For every C file, there's this object file rule. And what we can do is we can make a pattern rule. And a pattern rule is we're just going to have one rule for all of the object files. So we can do that, and then we can do that, and then this one, this is going to be replaced with this and this. So this one here is just referring to the C file that is going to be a prerequisite, and then here's the target. So instead of this one, instead of main.o, we're just going to do this and at. And then now we can get rid of all of these object rules here. So we have one pattern rule for all the object files, we have one rule for the executable, we have one rule for clean, one rule for all, and then let's go ahead and compile. Run make. Okay, now it does the same thing. So if you do ls, so now all the object files are here, and then the Huffman executable is there. So it basically does the same thing as it did before, but as you can see, it's a lot cleaner, a lot simpler. Our last thing we're going to do is we're going to, instead of putting all of these object files and the executable all inside the same directory as this Huffman directory, we're going to put the object files in an obj directory, and then we're going to put the Huffman executable in the bin directory. So we're going to create these directories here. These are typical for C projects: source, obj, bin. Then we can replace these with the source directory variable. We can make a target variable. We can replace this one with that. We can replace this with that. This one with that. We're going to put our object files in this obj directory. Replace that with the source directory variable. And then we want to create a rule to create the directories. So for the bin directory or the object directory, we're just going to use, these are again pattern rules. So for these directories here, we're just going to use this recipe, make directory, and then this is the @ symbols for the target. So if we want to create the bin directory, we just use this recipe, or if we want to create the object directory, we use this recipe here. And then the last thing we'll do is we're going to add something called an order-only prerequisite. So we're just going to do or object directory. Basically what we want to tell for this target here, we want to make sure this object directory exists first. So it's going to come here and create the object directory first before it builds all of the object files. And then likewise with the target, because we're going to place the target inside the bin directory, we want to make sure that we're also creating an order-only prerequisite for this bin directory as well. Alright, so there you go. We created some new variables for the source object bin directories. We replaced it where we thought it was appropriate. Let's update the clean rule. So we're just going to echo this string here. So when we run make clean, it's going to tell the developer cleaning up build artifacts, and then we're just going to remove these two directories. Because all of the files that we're generating are either going to be in the object directory, which are the object files, or the Huffman executable, which is going to be in the bin directory. So let's go ahead and run make here. Okay, so we go here, it's pretty clean. Now we just do make, and then it's going to compile all of our C files together, and then the last one is going to build that executable. Now we do ls again, so we can see inside the obj directory. This has all of our object files, and then we go inside the bin directory, and it has our Huffman executable. And then if we do a make clean, it's going to remove the object directory and the bin directory. And it has that cleanup build artifacts message for the developer. And then we do ls, and then we're back where we started. Alright, so there you go. That's how you create a Makefile. It's a pretty simple Makefile. It's intimidating at first, but once you understand the basics of Makefiles, it's pretty easy to follow. And then you can see here our source directory. This is all of our code here, but it generated this bin directory for our executable and this obj directory for our object files. Alright, that's it for this week's video. I hope it taught you everything that you need to know about Makefiles. If you have any other questions, feel free to let me know in the comments section, and I'll be sure to answer you there. And if you want to build this Huffman compression project yourself, the one that I went over in this video, you can check out this video over here, and I'll see you in the next one. Peace.